Hello students, we will continue with the next part of the lesson, that is light. Refraction of light through a prism. This is our topic. Okay, this topic comes under human eye and the colorful world. But human eye is cancelled from your syllabus. Human eye and its application are cancelled from your syllabus. So directly the next topic in that lesson is 11.3, 11.1 and 11.2 both are cancelled. Refraction of light through a prism. Okay. Already refraction, when light enters from a rarer to denser medium, it changes its path and it moves towards the normal. Okay. This refraction we have seen in case of a glass lamp. Now we are going to study refraction with respect to a glass prism. Okay. How does a prism look like? Here I have shown a picture of a prism. This is a triangular structure, triangles on top and bottom and 3 rectangles. See here also, this is how it will look like. So, when refraction occurs through this glass prism, what happens, that we are going to study. Okay. So refraction through a glass prism, just see, this is the diagram, this is given in your textbook also. Okay, now this is glass. Prism is made up of glass. Outside it is air medium. Okay, so air is a rarer medium. Glass becomes the denser medium. Here the density is more. Okay, now again you see here this ray, if you can see, this is the incident ray. Okay, incident ray means light is coming from this side and it is falling on the prism. Now when light is coming from this side, it has to fall on the prism and go straight. Do you see this dotted line? But instead of going straight, as it is entering from a rarer to a denser medium, this ray of light change its path and move towards the normal. Now just see, for this line of the prism, this is a dotted line. This is angle of incidence which it makes with the normal. And here you see it is moving towards the normal. Here you see angle R. Angle R is angle of refraction. Okay, then after going straight, again now here it is entering from a denser to a rarer, from glass to air. Again it is changing its path and now it is moving away from the normal, because this is a rarer medium, this is a denser medium. Okay, so this is how it will go about. Alright, so this will be angle of emergence, and you see angle E is bigger than angle R, that is angle of refraction. Okay, now actually the light was supposed to go in this direction. You see these dotted lines, and the emergent ray, see this one, this is the deviation, means change in angles. Instead of going this way, it went this way, and that is why called as angle of deviation, capital D. This is angle of emergence, E. This is a glass prism. This activity we will be performing in the lab as well. Okay, even the glass lab activity we are going to perform in the lab. Okay, so this is how refraction takes place in a glass prism. Okay, now quickly we will read the matter. Prism. It has 2 triangular bases and 3 rectangular lateral surfaces. So one triangle on top like this and one on bottom, and these 3 sides there are rectangles. These surfaces are inclined to each other. Inclined, okay, they are attached to each other. Angle between its two lateral surfaces is called angle of prism. Now whatever angle is formed here or here or here, these angles are called as angle of prism. Angle of deviation. Now the angle between the incident ray, this is the incident ray, and emergent ray. Okay, angle between the incident ray and emergent ray. This is dispersion of white light by a glass prism. So this is how it will look like. Okay, I hope you have understood this. This also we will read. When a ray of light passes through a glass prism, it's get bent twice at the air glass interface and glass air. Twice it is bending, here once and here one more. And the emergent ray is deviated by an angle of incident ray. Emergent ray deviated by an angle of incident ray. This angle is called as angle of deviation. This angle which is formed here by emergent and incident ray. Okay. Dispersion of white light by a glass prism. Now just see, I have tried to show you a figure similar to your textbook. This is dispersion of white light in a glass prism. Here something is missing, that is white light. It is written here white light. Okay, now when a white light is incident on a glass prism, what happens to it? Just we will see. The prism has probably split the incident white light into a band of colors. You see, after the white light has gone inside, you will see that a band of colors is formed, so many colors. Note the color that appears at the two ends of the band. Just see, at the two ends means top and bottom. Here you can see at the top is red color and at the bottom is violet color. The various colors seen are violet, indigo, blue, green, yellow, orange and red. See, violet, indigo, blue, green, yellow, orange and red. Okay. Just see these colors. The acronym VIBGYOR will help you to remember the sequence of colors. V stands for violet, indigo, blue, green, yellow, orange, red. The band of the colored components of the light beam is called its spectrum. This band of colors is called as spectrum. Okay, you might not be able to see all the colors separately. You will be means red somewhere else, and they are all together. Okay, yet something makes each color distinct from the other. The splitting of white light into its component colors is called as dispersion. In this white light getting splitted up into 7 colors, this is called as dispersion. Whereas these 7 colors together, they are called as spectrum. Okay, these 7 colors together, they are called as spectrum, and this splitting, this phenomena is called as dispersion. You have seen that white light is dispersed into its 7 color components by a prism. You can see it is split up in 7. Why do we get these colors? Why these colors we are getting? Different colors of light bend through different angles with respect to the incident ray as they pass through the prism. The different colors will bend through a different angle, means red will bend this much, orange a little more, yellow a little more than orange, then green a little more than all the above, like that. The red light bends the least while the violet bends the most. See, red doesn't bend the least. Okay, sorry, red bends the least, whereas violet bends the most, means that is why it is going last, you're bending the most. Whereas red doesn't bend the most. Okay? Thus, the rays of each color emerge along different paths and thus become distinct. Okay, so there every time every color is taking a different angle. That is why we can see them in one line like that. It is a band of distinct colors that we see in a spectrum. You can see a band of distinct colors can be seen over here. Okay, so this is how dispersion of white light through a glass prism takes place. Then recombination of the spectrum of white light. Okay. Now what is this recombination? Sir Isaac Newton was the first to use a glass prism to obtain the spectrum of light. Now he only actually did that previous slide. He only found out that one white light can make 7 colors. He tried to split the color of the spectrum of white light further by using another similar prism. Now what he thought, if I am getting, once I send the light to glass prism, I am getting 7 colors. So if again I put a prism over here, I may get 7 into 7. That is 49 colors. That is what he thought of. But it was not true. When he kept another prism over here, he could see that all the 7 colors are getting together and they are coming out as one white light. Okay. However, he could not get any more colors. Okay, so he thought 7 into 7 I will get 49 different colors, but he did not get 49 different colors. He got again one single light. He then placed a second identical prism in an inverted position with respect to the first prism as shown in figure. Just see, one he put straight and the second one inverted, means opposite direction, and then he placed a screen over here. From here he sent the white light, and from here you can see the white light coming out. Allowed all the colors of the spectrum to pass through the second prism. Okay, so then he allowed all the colors to pass through this. He found a beam of white light emerging from the other side of the second prism. So on the other side all the light came out. One white light came out. This observation gave Newton the idea that the sunlight is made up of 7 colors. So this is how he came to know that this one ray of light is made up of 7 colors. That means sunlight is made up of 7 colors. Any light that gives a spectrum similar to that of sunlight is often referred as white light. Any light which gives us 7 colors after refraction, that is called as white light. Any white ray of white light. Okay. Then you are already now familiar with all the colors in the rainbow, right? So we see then how the rainbow in the sky is formed. So rainbow in the sky. A rainbow is a natural spectrum appearing in the sky after a rainy shower. After a rainy day, you will see that the rainbow is formed, and there has to be sunlight also along with the rain in the opposite direction. It is caused by dispersion of sunlight by tiny water droplets present in the atmosphere. Okay, see, these are tiny water droplets which are present in the atmosphere. So sunlight enters here and it gets inside this water droplet, will act as a tiny prism. And then you see again here splitting of light into colors, and then you see the light coming out and you can see 7 colors. The water droplet act like small prism. They refract and disperse the incident sunlight, then reflect it internally and finally refract it again when it comes out of the rainy drop. So 2 times reflection, once and twice. Due to the dispersion of light and internal reflection, different colors reach the observer's eye. Okay, so due to dispersion of light and internal reflection, that is refraction of light. You can also see a rainbow on a sunny day when you look at the sky through a waterfall or through a water fountain with the sun behind you. If the sun is behind you and if you are standing in front of the water fountain, then there also you can see a rainbow in the water fountain. Not necessarily it has to be a rainy day. Okay, so this is how rainbow is formed. So these 2-3 points are important. That water droplet acts as a small prism, then it disappears, and then there is internal refraction of light inside the drop of the prism. Okay, so how is a rainbow formed can be one of the questions. It will generally come for 1 mark or 2 mark, give reason. Okay, children, so just mark the main points in the textbook and study this well. Okay, if you have any doubts, please contact me personally.